Hello. So for today's video, I'm gonna show you some chemical tests that are used to identify carbohydrates in the laboratory. Pay attention to the information presented here as this will be used to answer your laboratory case study. So the carbohydrates that we'll be using for today is ribose, glucose, fructose, lactose, sucrose, and starch. And we have water as our blank. The first test we're gonna do is the general test for carbohydrate known as the Molisch test. It will be using alpha-naphtol dissolved in alcohol known as the Molisch reagent and of course your concentrated sulfuric acid. The test is done this way. For these tests, once again, we will be using the Molisch reagent. So to 2 ml solution of each carbohydrate sample, we will be adding exactly 1 ml of our Molisch reagent, as you see in our screen right now. After adding your Molisch reagent, do not forget to shake the test tubes properly and you will get a light brown solution like this shown in the video. The next step for you to do is to pour down concentrated sulfuric acid at the side of the test tube while tilting it at 45 degrees. Make sure that the solution do not mix. And then, wait for the formation of a purple ring, which is basically the positive result for your Molisch test indicating the presence of carbohydrates. So as a result, all your carbohydrates did give a positive result of a purple ring. Your ribose, your glucose, your fructose, your lactose, as well as your sucrose, and also your starch, because all of them are actually carbohydrates, except for water, which is not. It did not give a positive result. The next procedure we're gonna do is the Benedict test. This is a test used to determine the presence of reducing sugar. To do this, we need to add 3 ml of Benedict's reagent to each 2 ml of carbohydrate solution, including your water. And then after which, you would need to mix it properly in order to have a good result. Your mixtures would then look like this. After mixing them properly, you would need to heat them in a boiling water bath for 2 minutes. The formation of a briquette precipitate indicates a positive result. In this case, your ribose, glucose, lactose, and fructose were able to give a briquette precipitate, so the 4 of them are all reducing. However, your sucrose and starch are non-reducing as they were not able to give a positive result. Your water is expected because it is not a carbohydrate. The next test is the Barfoed test. It is utilized to differentiate monosaccharides from reducing disaccharides. Like your Benedict test, it utilizes cupric ions as oxidizing agent, but is weaker because of its acidic condition. To do the Barfoed test, we need to add 3 ml of Barfoed's reagent to 2 ml each of your carbohydrate solution, and then mix them properly. Then heat the mixtures in boiling water bath for 5 minutes. The positive result is the formation of a briquette precipitate, which means that your ribose, glucose, and fructose are all monosaccharides because all of them gave positive result, while your lactose, sucrose, and starch did not. So was your water, which is basically not a carbohydrate. For our next test, we will be doing the Seliwanoff test. The Seliwanoff test is a very specific test to determine the presence of your ketosis. To do this, you would need to add 3 ml of your Seliwanoff reagent to 2 ml each of your carbohydrate solution and mix them properly. And then heat the mixtures in a boiling water bath for 2 minutes. The positive result is the formation of a cherry red solution. In this case, your fructose and sucrose gave a positive result. Fructose by nature is a ketose, while your sucrose is actually a disaccharide that would give a ketose upon hydrolysis. The next procedure we're gonna do is the Bial test. The Bial test is a chemical test that is used to identify pentoses from the solutions. To do this, we need to add 2 ml of Bial's reagent to 2 ml each of our carbohydrate solution and mix them well. After that, you need to heat the mixtures gently over a Bunsen burner flame until the liquid begins to boil. Observe for the formation of a bluish-green color. The result shows that only ribose gave a blue-green coloration, which means to say that only ribose is a pentose among all the carbohydrate sample. The final test we're gonna do for this experiment is the iodine test. This is used to identify polysaccharides in the laboratory. We will be utilizing iodine and potassium iodide solution for this. The test is so simple. Just add a drop of your iodine solution into your carbohydrate solution and wait for the formation of a blue-black coloration. In this case, your ribose is not a polysaccharide, so as your glucose and your fructose, your lactose as well, and your sucrose. Only your starch is able to give a positive result, meaning it is the only polysaccharide in the samples that we have here for today. So there you have it. I have just shown you some of the chemical tests that are used to identify carbohydrates in the laboratory. So you're now ready to answer your laboratory case study on the analysis of carbohydrates.